Hi class, today I'm going to show you how to rank atoms according to size based on a simple criterion. We're going to choose a bunch of atoms that have the same number of electrons. And when a set of atoms have the same number of electrons in them, they're called isoelectronic. And why would I do that? Well, it's based on the simple idea that most atoms, when they get a charge, are trying to achieve a stable octet. Having 8 electrons in the outer shell for some reason provides a more stable atom. So very often, and it's because it basically approximates the configuration of the noble gases. You'll see that all the noble gases, all the noble elements have a filled shell with 8 electrons in the outer shell. So when, for instance, when fluorine becomes fluoride by gaining 1 electron, it ends up having, instead of 7, it gains that extra electron to have a -1 charge. Now it has a filled shell of 8. With oxygen, typical charge on oxygen is -2. So oxygen likes to gain 2 electrons so that it can achieve a stable octet. Nitrogen likes to gain 3 electrons to achieve a stable octet. You see that the number of boxes it is away from the noble gas is an indication of the typical charge that the atom will typically take on. If you go to the other side of the periodic table and you look at sodium, sodium has 1 electron in its outer shell. So what metals typically do is they lose electrons. Sodium loses 1 electron to become isoelectronic with neon. So the nitride with a -3, oxide with a -2, fluoride with a -1, neon with no charge, and potassium with a +1 charge, sodium with a +1 charge, magnesium with a +2 charge, aluminum with a +3 charge, and silicon with a +4 charge, all have 10 electrons. And so I've shown you the Bohr-Rutherford diagrams here, I've pre-drawn them, of all of those elements. You see that nitride has 7 protons and a charge of -3. And when you look at the electron configuration, because it has a charge of -3, it means it has 3 extra electrons. And to get a neutral nitrogen atom, you only have to have 7 electrons because there's only 7 protons. But if you have 10 electrons, then the atom is going to have a -3 charge. The same rationale works for all the other elements. You see oxygen has 8 protons, but if it has 10 electrons, it's going to have a -2 charge. Fluorine has 9 protons, but with 10 electrons, it's got a -1 charge, and so on. With the metals, they tend to lose electrons to have positive charges. Now, if they all have the same number of electrons, but different numbers of protons, you can actually rank them according to size. The ones that have the most positive charge in the nucleus are going to pull those electrons closer into the nucleus, and it's going to make the atom smaller. So you can actually rank isoelectronic series. You'll notice that the biggest ones will be the ones that have the most negative charge. So nitride is going to be the biggest atom in this series. You see how I arranged them here according to size. Nitride is the biggest, followed by oxide, fluoride, neon, sodium cation, the magnesium cation, aluminum cation, and the smallest is the silicon cation. So tomorrow when you write your periodic table test, I expect you to be able to do this. So watch it through carefully and try to understand what's going on. And as well, also, you'll have to memorize all the different things I showed you on the periodic table. I'm also going to include a sheet with a clearer copy of the questions I'm going to ask you. I'm going to zoom in on the picture so you can see the questions more clearly. All right, so we'll see you tomorrow. Bye-bye.